So this was the first problem we solved together, and I asked you in class to solve it using whatever method you could think of. But then what I wanted you to work towards was solving the problem using algebra. So as I mentioned in class, what we want to do to start this problem is we want to think about what is changing. So what is changing in this problem is when we use algebra. Oops. What is changing in the problem? When we use algebra, we use letters. We almost always use letters. You could use symbols of some other type, but we use letters, and sometimes the letter X is used as a general variable, or you could use a letter that sort of makes more sense based on the problem, as we'll do in this case. But we use those letters to represent things that change. Things that don't change, things that stay the same, we have numbers for, so we don't need letters for those, or symbols. We can just use the numbers. So let's start off by asking in this problem, what is changing? Is it the pay rate? Is that what's changing from week to week? Is it the expenses? Does that change from week to week? Is it the number of hours worked? Does that change from week to week? And if we think about it, we realize that what changes from week to week is the number of hours. So the number of hours is going to be our variable. We're going to use a symbol or a letter to represent the number of hours, and we'll choose H to represent the number of hours. So that's the only variable that influences the results of this problem, H. So now what we want to do is we want to take the pay rate and the expenses for each of these two people, Joan and Chris, and develop expressions for their total pay. So let's start with Joan. So Joan's pay. If we wanted to calculate Joan's pay, we would multiply her hourly rate, which is 15.50, and we'd multiply that by the number of hours that she works, H. And then we have to subtract from that the $40 that she pays for uniform rental. So this expression here, this is an algebraic expression, 15.50H minus 40. And this expression represents Joan's pay. Let's now take a look at Chris's pay. And Chris only gets $14 per hour, so 14H would be her hourly pay, and she pays $35 in expenses. So this would be the expression for Chris's pay. Now we can add these together to get a total, an expression for the total pay. So combined income is how it's described in the problem. So the combined income in this example would be equal to Joan's pay, which is 15.5 H, H minus 40, plus Chris's pay, which is 14H minus 35. And we can simplify this a little bit more by adding together what we call the like terms. So this term here, 15.5H, and this term here, 14H, they're both multiples of H. So these are, we would call these like terms. And also, if we take a look at the numeric parts, the 40, the negative 40, and the negative 35, they are also like terms. So we can add together, we call it collecting like terms, or adding together like terms. So what we get if we do that, 15.5H plus 14H is 29.5H, and minus 40 minus another 35 is negative 75. And so this expression here is an expression for the combined income. So if we want to find the combined income of the two people, we can use that expression to figure it out. The second part of this problem then asks you to do that. So if they work for 38 hours per week, so if they each work for 38 hours, then the combined income will be 29.5. I use brackets to show these multiplied together. Multiplied by 38. So H is 38 hours, minus 75. Now, as was mentioned in class today, when you do this calculation, you have to follow the rules of BEDMAS. So BEDMAS, I'm just going to write it up here at the top. BEDMAS means this is the order in which we calculate things in mathematics. So brackets and exponents come first, B and E, brackets, then exponents, then divide and multiply, and then add and subtract. In this case, what we're doing is we are multiplying here, and then we're going to subtract this. So when we do that, we have to do the multiplication first, according to BEDMAS, and then subtract the 75. So if I follow that order of operations, what I get is, when I multiply 29.5 by 38, I get 1121. And then I subtract 75. Put that in again, 1121 minus 75. And if I calculate that, I get, for my final answer, $1,046. This problem has units in dollars, so I should put that in the answer. So you can see, if we just go back to this this equation here, on this statement here, 29.5h minus 75, we can use that to calculate the combined income for any value of h. So that's why writing algebraic expressions is more efficient than just figuring out from scratch each time the number of hours changes. If you were going to create a computer program or use a spreadsheet to calculate your employees' pay, then you would want to put a formula like that together rather than recalculating it from scratch every time. It would be very time consuming to do.